These are the problems from page 4 of the study guide for Algebra, benchmark number 2. Let's take a look at this one right here. We have a mixture problem. And so mixture problems, remember, we're going to end up setting up a little chart. The chart goes this way. We have an amount of solution. And so start off with that amount of solution, and then after that, we're going to end up multiplying it by a rate. Take that amount of solution times by a rate, and the rate in this case is a percentage. It's a percentage of whatever we're dealing with, in this case a salt. And from there we're going to end up getting an amount of salt. And so let's go ahead and figure out what are our parts. And so remember, you've got two parts that you're bringing together. So we'll call this part number 1, part number 2, and then we've got a final mixture, a mixing of these two parts, which we'll call the mix. And so I'd have to end up spacing this out a little bit to give myself a little bit more room, so I think I'll do that. And so we look at 2, and then we got our mix down here. And so for the first part, we've got a 30% salt. A solution containing 30% salt is to be mixed with one containing 50%. So those are the two parts that we're going to end up mixing together, a 30% and a 50%. Well, they're going to make. Now the words to make gives away that we are now dealing with the mix. So look for those. And they might not say to make. They might say to get, to obtain. Any of those phrases, that tells we're dealing with the mix. So it's a 200-liter solution. So 200 liters. And it is of a 42% salt solution, so 42. Now I typically leave them in the percent form rather than changing them to decimals. It won't give me an exact amount of salt in liters, but we can go ahead and solve for it without having to deal with decimals. So we should find both. So we call one of them x, and one of them is going to be the total minus x, and that's the key. Whenever you're given a total, that means one of the parts is x, the other is going to be the total minus x. And we'll see that in another problem as well. So now we go ahead and multiply these amounts. So let's see what we get. We get a 30x. Here we have to use the distributive property, so we get 10,000 minus 50x. And then over here we get 42 times 2 gives me 84, and it's 8,400. And so these two amounts get added together. And so when I add those two amounts together, I can combine some like terms here. I can take 50 from 30, and that gives me a negative 20. Negative 20x plus the 10,000 equals the 8,400. And so then I can do some simple math by subtracting that 10,000 from both sides. Now remember, go ahead and put the rest of the work up here since I'm running out of room. Negative 20x. Negative 20x equals, and then when we do that subtraction, we end up with a negative 1,600. So make sure you borrow when you do that work and put the bigger number on top, or else you'll make an error. Divide by negative 20, and we'll get our answer. Well, 2 goes into 16 8 times, with one 0 because this 0 will cancel out this 0. So just 80. 80 liters. And it's of, well, which one? Well, it's x is the 30%, so it's 80 liters of 30%. Well, moving on, well, actually, we've got to find the other one, so let's go ahead and put those 80 liters in for this expression right here. So put 80 right here, take it away from the 200, and we get 120 liters of the 50% salt solution. Well, another problem here, a little different though, and what's different about this one is that we are not given the total. So let's take a look at it. Amount of solution multiplied by a rate, which is a percentage of salt again, and it equals an amount of salt. So we go ahead and substitute our numbers in here. Reading it off, 280 liter solution is 20% salt. Okay, so we've got a solution. It has 280 liters, 20% salt. Okay, how much? There's our variable. We don't know how much. So that's our variable x. So that's where the x goes this time. How much salt should be added? Well, salt should be added. We don't know how much salt should be added. So this is going to end up being 100%. We have a 100% salt solution. And how much is it going to make? Well, it tells us right here. So right here it says to make. To make means that we are now dealing with the mix. So right there is our mix. So we're going to make a 36% solution. So 36% goes right there, and these two get added together. So we end up with a 280 plus x right there. And then we go ahead and multiply. So we go ahead and multiply those numbers. 28 times by 2 gives me a 56, and I carry on 2 zeros. Over on this side, I've got 100x, and over here I have to use that distributive property. And so when I do that, I end up with a 10,080. 10,080 plus 36x. So I go ahead and do some work there, and I've now got a 5,600 plus 100x, and this all equals 10,080 plus 36x. So we do some math there. We got to do some opposite operations. Subtract that 36x from both sides. Subtract that 5,600 from both sides. And this is what we now have. We now have a 64x equals, and then you got to borrow a little bit, so be careful with that subtraction. Got to borrow all the way back. Let's see here from this 10 here, and we end up having to borrow from the 10, change it to a 9. This is a 10, so we end up with 4 and a 4. So 64 into 4,480. So we go ahead and do the division there, and we end up with x equaling 70. So 70 liters of salt is what's needed. So the key thing there is that if they say just how much salt, well, so how much, what is the percentage of salt? 100% is what it is. So that's why that was 100% there. Another problem, this is similar to the first one that we just did. We have an amount of solution, and we're going to multiply that by a rate. And the rate is a percentage of chlorine this time. And we're going to get an amount of chlorine when we multiply those numbers together. Well, we go ahead and set up our problem. We substitute what we have. It says a solution containing 28% chlorine is to be mixed with. To be mixed with, okay, that means we're combining these two together. One that's 40%. So we got a 28%, a 40%, and then it says to make. Again, remember that key phrase there tells us that we're dealing with the mix. So we have a 300 liter solution that is 36%. Again, this is our mix because of those words to make. Gives it away. Well, we don't know how much of the 28 or the 40 we need, so we need to find them both because they say how much of each do we need. So one of them's x, and whenever we're given a total, it's the total minus x. So we go ahead and multiply across. We get 28x. Over on this side we get 12 with 3 zeros, so 12,000 minus 40x. Over on this side, 3 times 36 gives me 108 with 2 zeros. So we just add these numbers together. So the common mistake people are going to make is right here in this subtraction. So people sometimes say it's 28 because they don't borrow, but you got to borrow. You end up with negative 12x plus 12,000 equals 10,800. So when we go ahead and do this subtraction, what you might end up doing is do this. See, I subtract that 12,000. Rather than to have to rewrite it, why don't you just put it up top here and do the subtraction. Then you can borrow. So we get 0, 0, borrow from the 2, change it to a 1, end up with 12, but you got to note that you're taking more away than what you started with, so it's negative. And you should get those negative signs to cancel. If you're not getting those negative signs to cancel, you're doing something wrong, so check that out. 100 is what we end up getting, 100 liters. Now which one is it of? X is the 28%, so of the 28%. So we can go ahead and put that 100 right here in place of this x, subtract it, and we get 200 liters of the 40%. Well, those are some mixture problems. let's take a look at some other ones that we'll end up seeing. So we've got a distance, rate, and time problem that we have to deal with next here. It talks about Ted's average driving speed is 80 miles an hour. All right, distance equals rate times by time. So that's our little formula we're going to use. It even says it right up here. His average driving speed was 80 miles an hour for a 5-hour trip. Oh, they're giving us a rate and a time. Well, let's go ahead and multiply it to find out how far they went. That would end up being 40 with a 0, so 400. And note that this is a total distance. Total distance. All right. Well, during the first 4 hours, okay, that's a time, he only averaged 65 miles an hour. Okay, so we have another distance we can come up with. Let's go ahead and multiply those two numbers. I end up with 260. All right, well, it says, what was the speed? What was his speed for the remaining hour? Well, we don't know that speed, so that's where we put our variable. But we know it was 1 hour. Now we just don't know the distance. But how can we find this distance? Well, right from what we had been given before, if we subtract these two numbers, we'll get our answer. Make sure you borrow. The 4, change it to a 3, that to a 10, 140. Whoa, he's going pretty quick. Must be in Montana or Nevada or something like that, where they got a lot of flat roads, maybe the eastern end of Montana. 140 miles per hour. He was flying that last hour in order to average a 60 or an 80 mile an hour trip. Seems a little off, but just the numbers were given. Well, let's take a look at this next one here. 2 cars leave town at the same time, traveling in opposite directions. Let's draw a little picture. There's the town, those are the 2 cars. And one travels at 40 miles an hour. So let's go ahead and start writing our formula up here. So distance equals rate times by time. This is my R here for rate. 40 miles an hour, okay. And the other at 45. Now, we weren't given any times this time, but let's look back at what it says. They leave town at the same time. We don't know what that time is, but we know it's the same. So let's use a variable. We'll use the same variable, t. Now I've got to figure out what their distances are. So it says that in how many hours will they be 255 miles apart? Well, neither has traveled 255 miles. Both of them combined to equal 255. See, the first car is right here, going a little slower, so shorter distance. The second car is right here, this distance. So together they make 255 miles. Well, let's do this. Let's call the first car here, that's only traveled this portion of 255, let's call it D. So I'll put a D for its distance. Now, how would I write the expression to represent the other car's distance? Now note, if I draw this line, let me take this line here, right here, you're cutting this portion away from 255. So that kind of gives it away. So you're taking D away from 255. So the other equation has to be 255 minus D. And then from there we can go ahead and solve. See, here we can go ahead and just add these equations together. See what will happen? The D's will end up canceling. We're left with 85t, so I have to add those two together, equals, and this makes 255. Well, I do that division, and it just so happens to go in there evenly. So what you might end up doing to do that division, because it seems hard, cut off these 2 last numbers right here. Cut those off. Do 8 into 25. How many times? It goes 3 times. Well, let's just try 3. Let's do 85 into 255, and let's just see if 3 ends up working. See, 3 times 5 makes 15, carry a 1, 8 and 3 make 24, and 1 make 25. It works, so 3 hours. There's the time. Well, the letter C on this part here is cut off. We'll do it in the next part, you can check.